is how we roll, man. Some rock, some win, some roll, man. Some rock, some win, some roll, man. Some rock, some win, some roll, man. Some rock, some win,
Hi, my name is Loris Crow, and we are executing a Showtime. Zig SHOWTIME is a show and a community for makers. Watch the show to learn about interesting projects, and join the Discord server to share what you're working on, and to collaborate with other members of the community. And if that's not your style, or you're new to Zig, make sure to check the other Zig communities to find one that suits you best. Now, you might be wondering why your show is a ghost, and the answer is that it's tough being both producer and host. And since today I'm hosting a Zig RUSH with Andrew, my camera is occupied by Discord, and that means I can't show myself in this view. But I can show myself here, and with me there's Andrew. Hey Andrew, how's it going?
Hey, great. How are you?
Pretty good. Wait a second. Why is my Discord being bad? Oh, okay. So new setup, and I'm discovering new quirks in the system. The video was frozen. Okay, so are you ready for a Zig RUSH?
Oh, absolutely. I love watching people's projects.
Yeah, I saw a couple of people showing me what they were working on while we were doing tests, like audio video tests, and yeah, it seems we have some pretty cool stuff lined up. So as a reminder to everybody how it works. So Zig RUSH is kind of like lightning talks, but with a twist. You're not supposed to, or at least the way I saw lightning talks being done usually at conferences, people have like these very compressed slide decks with like pictures and concepts, and they talk very fast. This is not exactly like that. The idea is that you don't even have to have a slideshow. You come on the stream, you tell us what you're working on, you show us how far you got, maybe we ask a couple of questions, and then we move to the next person. So it's like lightning talks, but focused on showing stuff that people are working on. Now, for also, there's no sign-up process. So aside from the people that wanted to do a audio video test with me earlier, I don't know what they're going to show, and I think Andrew doesn't know either. So the way it works is that all you have to do is join the Zig SHOWTIME Discord server, join the waiting room voice channel. You stay in there. I'll send you a Discord message asking you when your turn comes. I'll send you a Discord message asking you if you're ready. Once you confirm, I'll put you into the voice channel. You can start your screen share and show us what you want. That's pretty much it. So I see there's already a couple of people lined up. Maybe I'll give people 5 minutes more to see if there's more people that want to line up there. And yeah, and then we can get started.
Can I mention something?
Sure.
I noticed that a lot of people have stuff that they're working on that they would want to show, but they don't feel like it's polished enough. So I just wanted to encourage people that it's okay. There's a low expectation of polish in Zig RUSH. Is that correct?
Right. That's a very great point. Yeah, we are very curious to see what you're working on, and it's fine if you don't have like a complete project. I agree. That's the whole point, right? If you do have a complete project, you should apply for a full talk.
Yeah. Got him.
So I hope this kind of explains what Zig RUSH is. So while we wait for people to make up their mind, and seriously, like if you're on the fence, don't worry. Again, it's gonna be fine. While we wait,
yeah, this is not a judge panel. We're just here to have fun, right?
Yeah, no, exactly. I mean, also, You've seen me live stream. It's like, what do you expect am I going to tell you? Yesterday, Andrew, I was trouble parsing numbers from a string input. Like I was adding the FK functionality to Borg, right? My chat client, and like I was writing a parser for time formats like 1 hour, 1H, 25M, like human friendly time formats, was more difficult than I expected. In any
Yeah,
case,
deceptively complex. Yeah.
yeah.
You almost have to go full tokenizer parser on that.
You need state. One thing that I wanted was that you needed to, like, you can omit higher time format, higher units. Like if you don't have hours, you can omit hours, but then you cannot add hours afterwards. So yeah, you need state transitions. Anyway, back to the main topic. So just so everybody knows, we are going to Handmade Seattle next week. So what is it? 5 days from now? So are you
Yep.
excited, Andrew?
Yeah, I was always excited, but I was a little bit nervous because I hadn't started working on my talk yet. But now I'm almost done with my talk, and I'm really happy with it. So now I'm just excited.
Awesome. That's pretty nice. Yeah, let's hope that everything goes well and we can have also a small Zig meetup there. Okay, let's have people come. So let's start. Okay, let's start from the bottom. Let's start with Luke. So let me send a message to Luke. Are you ready? Question mark. Mute the stream. One thing that I always remind people is the.
Oh, right. Otherwise, you hear double.
Yeah, otherwise it gets crazy. Okay. There we go. Hello.
Hello, good
Hi,
evening,
Luke.
everyone. How are you guys doing?
Pretty good, pretty good. What are you showing us?
Good to hear, good to hear. Well, I was kind of forced by Jakub to demo the linker that I've been working on for specifically WASM. So I'll be showing two little demos, one that uses Zig and C to make two object files and then link them together. A simple hello world, basically.
Okay.
And someone in the community made a very fun snake game that they compiled to WASM, and I'm going to link that project with the linker I've been working on. So
Nice.
I'll be sharing my screen. All right. So you should be able to see my screen right now. I see.
Yes.
So I made two small files here. So I have a test.zig, which is basically we have an external function that we import, and we have our start function that basically just calls this function.
Okay.
And we have some C, which basically implements the function, and all it does for now is just returns 5. So if I go build two object files, one is for the C file, and we're going to build one for the Zig file as well. As you can see, we're targeting WASM. So now I have a test2, a test2.o file and a test.o file. And then when I run the linker, which is called ZWLD, no final name, it's all just experimental. And we call it on the test.o and the test2.o. We give it some output name. Let's call it test.wasm. And then you can see we have a new file, test.wasm. And when I run it inside wasm time, we get our number 5.
Yeah.
Nice.
Hell yeah. Talking about unpolished code, there's a lot of unpolished code in here, but the whole skeleton is there. So now it's just busy work, basically. So the second project is a small snake game. So if I go to my browser here, you'll see a snake game. So when I press spacebar, nothing happens because we haven't built the WASM file yet. So when I show you code for that, it's quite big actually, as you can see. Very big. And then we're going to make an object file for that. So
Those messages are funny.
I have so much history of all like building object files everywhere. Then unfortunately, we're also kind of relying on the optimizer to remove some of the symbols that will be undefined because I haven't implemented allowing undefined symbols just yet. And then when I show you the directory, it's probably in here actually.
Main.o?
Am I so blind? Oh, yes, yes. So when I run setup main.o and going to actually put it into correct directory this time, and I'm going to call it a main.wasm.
Oh no!
Oh no!
Uh-oh.
Oh wait, no entry. See, that's actually supposed to happen. Missing symbol.
Oh, good. Yeah.
Yeah. Error checks built in. Okay. So now if we check the directory, we have our main.wasm. Then I'm going to update to make use of it. Then go back to the browser. And now we can play the game.
Very nice.
Nice.
Can you
So,
bite
yeah.
yourself?
Yeah, this is so addicting. I ended up playing the game more than working on the linker. So yeah, that was it basically. The whole skeleton is there. So like I said, there's just a lot of busy work right now implementing all the leftover features, all the flags. But yeah, looking forward to be able to upstream some of this and work on incremental linking, which is hopefully going to be really fun.
Very cool. Are you looking for contributors to help you out?
Yeah, actually, if anyone is interested, let me know. Then maybe I can define some issues in the repository. And then I'm very happy to mentor as well. As you heard, we're going to Handmade Seattle next week. I'll be there as well. So it will probably be when I come back. But yeah, definitely hit me up on Discord, IRC, GitHub, wherever. Let me know if you want to have fun with this, and I'm happy to help out where I can.
Awesome. Look, I also have another question though.
Yes.
When new plushes?
You're making me announce it early.
Oh, then don't.
Oh,
Okay. Then
that's a
don't.
secret hint.
Oh, then don't. Awesome. Well, thank you very much. That was really nice. Looking forward to seeing the incremental compilation stuff also work on WASM. That's gonna be amazing.
Yeah.
Yep. Is there anything else you want to say before we move forward?
Nope. Looking forward to all the other demos and talks of the others.
Neat.
Thank you for having me.
Thank you for coming. That's awesome.
You're welcome.
Okay, so next is gonna be let's have Marler. No, sorry, let's have Joachim. Sorry, I think I'll do Joachim and then Marler. So in case everybody wants to start preparing. So let's find Joachim. Ready? Question mark.
I don't think I know what Joachim's working on.
Yes, you don't know.
Huh.
He showed a little bit of it early, and yeah, it's funny stuff.
Nice.
Hello.
Hi, can you hear me?
Yes. Hello, Joachim. How are you?
Okay, perfect. Okay-ish. I still have a cold. Hopefully
Oh.
it's only a cold, but yeah.
You're not scheduled for traveling, right?
No.
Okay, then that's good.
Yeah. Okay, so I'll share my screen.
Yes.
Something interesting I'm showing today. Yeah, and it's like a kind of a story of how Zig almost got used in production, namely for the orientation week in our university. We have a YouTube live stream, and to make it like interactive, and we have like interviews with professors and kind of small bits. So to make it kind of interactive, we want viewers to ask questions. We don't want to use the YouTube chat feature for that. We want to have like our own like special.
I wonder why. Why you wouldn't want to use YouTube chat?
We enabled the YouTube chat 1 year ago in the first digital orientation week, and that was a mistake. Yeah. Like, I mean, the YouTube chat of Zig SHOWTIME is like it's like a comparatively like a smaller audience, and it's very easy to moderate. But yeah, once it's in the uni with orientation week with so many participants, yeah,
Yeah.
it gets a little difficult. So. Last year we used a like free online live Q&A thing, but like that crashed under our load. Even though our load is like only very maximum 1,000 simultaneously online participants. But even under that load, it crashed. Which I still wonder how, but yeah, that happened. So for this year, we needed a tool, and we wanted to self-host the tool. And I decided, yeah, that's an interesting job. I'll do that in Zig. And then it almost got done in Zig. But then I realized I needed to implement like stuff like session cookies and rate limiting, where like I would have to implement it from scratch, and the time frame just wasn't adequate enough for that. So I just decided to do it in Go for the yeah.
Yeah, we need that ecosystem.
And yeah, right. So it was almost perfect. But yeah, I just used the Go, like already the Go has Redis libraries. I use Redis for the backend, and has rate limiting libraries, so everything fine from that aspect. But you know, it's Go. You know, you get that error not equals nil often, and yeah. But it's fine. I mean, I respect Go. It's a fine programming language for stuff like this. But yeah, the original goal was, of course, to implement in Zig. And after the orientation week, when I had more time, I did that as well. And yeah, it looks even cleaner I think. I used Loris's Redis library and Luke's excellent apple pie library for this. Yeah, so yeah, I can maybe show that in like live here. So it's a very basic tool. The front end is written in Svelte, which is also used by another Zig project by the I think the package manager, where I also got the inspiration from that. So yeah, so this is the interface you get if you are not a moderator. So you can ask a question like, "What is love?" And questions are initially hidden because they are subject to moderation, and then you can enter if you're a moderator, you have the password. In this instance, the password is ASDF. So yeah, and then this is like the interface you have as a moderator. You can show it. So even for non-moderators, it's viewable. And then other people can upvote this question. So if you look at the question list and say, oh yeah, I had this question too, and then you can say, oops, upvote. And everyone can only upvote one time. That's where the session cookies come into play. And then, questions can also be then deleted once they're answered. And there's also this handy delete all questions button, which is also useful. And export in the case when the time is up for Q&As, there's still questions open. Then you can export them and then answer them in a separate like a Discord post or in a something like that. Yeah. And I should mention this is not the Go version. This is the Zig version. This is the Zig version implements everything except the rate limiting, which is why I didn't. This is still running on my local host, not on a server. But yeah, so this is the Zig version. This is like everything works on the Zig version. So yeah.
That's cool. It shouldn't be too terrible to implement rate limiting. Also, you can cheat a little bit if you have Redis. You can have it do some of that for you.
Yeah, I know. Yeah.
How was your experience doing web dev in Zig then?
It was okay. So like web development specifically, the front end stuff. I never really touched JavaScript before or Svelte for that. So yeah, it was okay. I think mainly because of Svelte. It's a pretty simple project. So I can show the Svelte source code. So it's pretty simple. So I just have like these functions for everything, for every action, and then I have the thing here, and CSS is Bootstrap only, so I think one can see this. So so that was all pretty okay. And
what about the Zig side of things?
Mainly the apple pie library makes stuff very easy. So it's just nice to have like this router for every API endpoint, and then have I would even say it's even more comfortable than Go to do this here with the apple pie library. And also the Redis library for that matter, Loris, is also I don't have any complaints at the moment.
Pandering there a little bit there.
Thank you.
Just kidding. Cool. I have a question. How much memory does the Zig server use versus the Go server?
Oh, I haven't tested that yet. But the Go server, like it's ridiculously low, even in the Go version. So I think I once looked at the stats while it was running. And while I don't have I can't see how many people are connected, but I assume it was like 500, 600, and so in that ballpark. And the memory usage was like 15 megabytes for the Go version. I haven't tested it for the Zig version, also with that magnitude of clients. But yeah, I don't know.
It'll be interesting to find out.
It's probably similar or less, because like it's the allocation strategy is pretty simple. For every request, I have an arena, and then after the request is handled, the arena is freed. It's a built-in feature in apple pie. So yeah, it's
wow.
It should be a pretty low memory usage. Yeah,
pretty neat.
Nice.
Low fragmentation, I bet, on that one.
Yeah.
Awesome. Well, thank you, Joachim, for sharing. That was pretty fun. Also, thank you for the PR that you sent to OK Redis while I guess you were working on this.
Yeah.
Well, is there anything else you want to say before we move forward?
Yeah. thanks for having me here, and I look forward to the other stuff people want to show. Yeah, I'm really interested. Yeah.
Cool. Well, thank you again. And okay, so let's move forward. I think next is Ed, right? So,
1 sec.
oh, what's up?
Nothing. I just needed to turn off the space heater.
Okay.
It's getting toasty.
So, ready? Question mark. Make sure to mute the stream. It's always good to remind people.
Yeah.
Never hurts.
Yeah, it usually happens once per showtime, right?
Let's see, what are people saying on YouTube in the meantime? Okay, everything is fine in chat.
I see Luke's comment.
Okay, I'm not getting a reply from Ed right now, so let's bump somebody up. Let's go with Marler, who was also in queue. Ready? Question mark. Yep, the stream. Oh no, wait, Ed is ready, but he didn't reply to me. Okay, wait. Okay, one sec. Ed seems live. Okay, so okay, let me try to pull in Ed and let's see where that brings us. Ed, are you alive? Just so you know, you're muted, so you'll need to unmute yourself to speak. Can you hear us?
I think he's unmuted, but now the mic is not
Yeah.
sending us any audio.
Yeah. Oh, we might have video. Keyboard might. Let's go.
Let's go.
Almost there. Oh no. Almost there, but not quite. Okay. Okay, let me move Ed back to the waiting room. I'll send Ed a message and then pull in Marler. Sorry, we can't hear nor see.
Yeah. Ed, do a mic check and a video check, and then try again.
Yeah, also please send me a message in Discord, like in direct messages, so that I can actually confirm that you're receiving my messages. Okay, let's have Marler for real this time. Okay. Let's see. Pulling him in. Hello, Marler. How are you? Also know that you're muted.
Good.
Nice.
Awesome.
Hello.
Hey, Andrew. I'm excited to see you guys next week. It'll be fun.
Yeah, it's gonna be fun.
Nice.
I think we're staying in the same hotel, actually.
Yeah.
So, what are you going to show us?
I thought I'd give like a quick little demo of 3 things I'm working on at the moment.
Wow. Okay.
I think the other day I sent a message that I asked somebody to write a terminal in Zig, and then I thought, oh, that would actually be really fun. So I just started writing it, And the really fun part is I learned about X11. So I started out using libx11, got like a window working, and then I realized, oh, you're not supposed to use libx11 anymore. You're supposed to use libxcb. So I changed it to use xcb, and then I changed it to use Zig. So here we are with the Zig library. Here's a little example. So this is using the X11 protocol to make a window, display some text. We can query the text size and center it correctly. I made a little font
Are you intending
viewer.
to share your screen right now?
Yes. Let's see. Screen to go live.
There we go. Okay. Oh no,
There it
wait,
is.
almost. Okay, now we can. Yes.
Okay, great. So here's the little example window. It says hello. And this is all pure Zig. So it's just opening a socket to the X server and sending and receiving messages, which turns out isn't as complicated as I thought it was. I made a little font viewer. So the way fonts work in X. Oh, I can't move the window because I haven't implemented. Oh no, I got it this time. Okay. So this shows you like all the fonts that the server supports. Like this isn't how fonts work in X11 anymore. The client usually does it, but wanted to get this working so you can see all the server fonts. So those are the demos.
Is that Windows?
Yeah.
Oh, that's interesting.
Yeah, so I'm running MOBA Xterm on Windows and connecting to that.
Huh, that's cool.
Which is why it didn't work when you ran it the other day, because I haven't tested it running it, like connecting it to an actual Linux X server. I don't have one. So anyway, so here's the terminal I made. Zig build run. And there it is.
Cool.
Nice.
Zigterm.zig. There's the source code. You can't scroll. It's obviously very crude, but it's all in Zig, the whole thing, which is the really cool part.
That's cool. Are you gonna time how long it takes to cat a 2 GB file?
Like Casey, yeah, I definitely should. No, actually, I want he put out a set of videos that talked about how he implemented it, and he actually gave me the idea for a circular buffer. So,
Cool.
I actually use the exact same circular buffer he describes, which is to map the memory 3 times in a row.
3
times. You never have to
times.
move. Yeah, 3 times. So you can actually go like back before it.
Oh, yeah.
And it's not like it costs anything. Like.
Right. It's just the virtual memory mapper, whatever
Yeah,
it's
just
called.
the process. Yeah, it might be an entry in the MMU or whatever, but it's trivial. So yeah, maybe when it's more finished, I'll time how long it takes to cat a 2 GB file.
That's funny.
So that's Zig term, and I don't know. Let's see how much code it is.
Can you run Bork in it?
I may have tried that yesterday. Obviously, no. Like I don't support cursor support, but it would probably print out a bunch of weird characters.
It's funny.
But I actually did like add support for term info. So if Bork, I think, uses a term library, so it would probably know right away, hey, it doesn't support it.
Oh, you mean like capability checks?
Yes, capability checks.
About that.
Okay, maybe you didn't implement it. Here's my whole capability file. So
okay, so here's a fun test. Have you tried running Zig build? I don't know, run the behavior test or something with it, where it prints that that little progress bar where it says like semantic analysis.
I haven't.
That could be interesting.
Zig build test.
Yeah, look at it go.
Yeah, so it just keeps printing it since I don't support carriage return yet, I guess.
Oh, there it is. Yeah.
And I can't. It doesn't like change size it either. But yeah, that might be coming. We'll see. This is more like educational for me, but
Yeah, of course. Yeah.
maybe I'll like make it good one day. We'll see.
Super cool.
So, yeah, I'm just so excited it's all in Zig. Like, now I get all those benefits.
Yeah, it's nice
So-
when the project defines a protocol, right? Because then you can use any language
Right.
instead of like Pulse Audio, where I mean, technically there's a protocol, but really you just have to use like lib Pulse Audio client or whatever.
Yeah, and the protocol is actually not that bad to look at. Here's the protocol, and it's all just right here. It's kind of
Oh.
like weird, but like here's how it defines the messages. But yeah, if you want to know about X11, that was one thing I didn't like about libx11 and libxcb, the C libraries, is you have no idea how it's working under the hood. You call open display and then you call draw, and you have no idea when it's sending messages, when it's caching things. It's so abstracted. You have no idea what's going on. So the way I did this library is there's hardly any abstraction at all. If I look at the example, you can see what I'm doing here. So this is sending the background to create a graphics context. So I make an array on the stack with a length. I serialize the message into it, and then I call send on a socket.
Cool.
So there's nothing abstracted. I might like make an abstraction above it to make it more convenient, but the goal here is to just like really understand how it works and make that level of control available.
Yeah.
Comp time's cool too here, because like some of the messages depend on a parameter, but I execute them at comp time.
Oh, nice. Yeah, I get it. Yeah.
So that was one really sweet thing. Like I just code the logic to get the length, and I can do it at comp time and make a statically sized array for my message. That's pretty sick.
That's the main motivation for comp time. Like I know people like to try to do all these cool creative uses, like the router thing, which is undoubtedly cool, like the apple pie router we just looked at. But that what you're showing right there, with just a simple like, can my length function please just work at compile time? That's like the main motivation for it.
Yep. Yeah, that's super cool.
Neat.
So I guess I'll quickly show number 2. So number 2 is just it's a bootloader and the start of a kernel. And I originally had this written in D, so I'm porting it to Zig. So I'll just
Love the
run
name.
it here. Maros. Yeah. So this is using Kimu. This is my bootloader output. I'm pretty proud of my bootloader. I implemented like a poor man's register printf. So you put your variables in registers, and then you call printf, and then you put register offset, stack offsets in your string. So each time it sees one, it just goes to the stack and prints that. I'm really proud of my bootloader. And it all has to fit in 438 bytes because it's in the master boot record.
Oh.
And then after it loads the second stage can still call that printf function. So it's versatile enough to do that. So I'm working on that, just showing that it works, and if anybody's interested.
Oh, sorry, go ahead.
I was gonna say, if anybody's interested, it's at github.com/marler8997/maros.
Cool. I feel that there's a play on words here, something with macros. There's a joke here somewhere.
With Maros?
Maros and macros.
Well, it's from my last name plus OS.
Yeah.
Oh.
Yeah, maybe.
I think we need a little bit more adventurous names when it comes to this stuff, though. With all due respect, but like BoxOS, MarOS, I don't know. We need something more catchy. Like if you want to capture people's attention, you need something, I don't know, Multiverse OS nowadays.
Mario OS.
Mario OS.
That's ideas. So anyway, that's a fun project if anybody wants to check it out. And the last one is the Zig toolchain. So this is just me experimenting with a proposal.
I know what. Yeah. Okay.
So I'll just show you like how it works. That's the wrong window here. So this is a project I wrote in C++ that implements an NFS server for Windows. And it's got a build.cmd script. So it just calls the Microsoft compiler. So the goal of Zig toolchain is you should be able to run this with Zig without having to install anything. So let's see what that looks like. You run the Zig toolchain. So in the future, this might look like this: Zig toolchain, and then the toolchain you want. So here's the actual tool, and I'm going to emulate the MSVC toolchain. So I run that, and it installs a compiler wrapper around Zig-C that behaves like Microsoft's compiler, like command line switches, and translates them. So it gives you a batch script to run to enter the environment, and the reason for that is so you can set your path, because a subprocess can't set the path, so you have to run a batch script. So I'll run that, and then I should just be able to run the build command.
Oh, cool.
Yeah, there's some errors, but that just kind of shows you how it works. I think a lot of these are like min-GW header issues, but
Yep.
But the problem, right, is that if you want to compile something that works on Microsoft compiler, like if you want to have full coverage of everything, you'll need also to implement all their extensions, right?
You mean like the command line flags and stuff?
Well, no, I mean, I don't know. I'm assuming, maybe I'm wrong, but I think they also have like macros that aren't available on other compilers, stuff like this. Do they not?
like you're talking about language extensions?
Yeah, like stuff that works on the MSVC compiler, but that doesn't work on Clang, for example.
Yeah.
Yeah, you'd have to change the code to be more portable.
Mhm.
Yeah, you would.
Oh,
Speaking,
good.
I was gonna say, speaking of the 2 gigabytes, here's the ref term, which I was actually using this as one of the test cases. But go ahead, Andrew, while I build this.
Oh yeah, I was gonna ask you. Didn't you start working on trying to generate like basically a Windows.h from the Microsoft metadata? How's that going?
I got to a point where I could generate all the header files in the layout that the metadata has them in. And so the next step was to generate them in the same layout that the C headers are in. And so I was like thinking how to do that, and I ended up taking Vexu's C preprocessor.
Oh wow.
And getting
Okay.
it, yeah, and getting it wasn't that hard, and I got it to preprocess all the headers. And so but I don't know, it's kind of complicated, and I like took a break and took a step back from it to think about it more.
Yeah, fair.
Because I'm basically like re-implementing what the metadata project's doing at this point. So
Oh, I see. Yeah, I was always kind of confused how that would work because I mean, doesn't the real Windows.h basically have a bunch of macros and stuff that Win32 metadata does not provide?
yeah, but I don't think it's that many. I think I don't think it's that many. You could do those
Okay.
ones by hand.
Got it. Interesting.
So here's the ref term build script running with Zig toolchain.
I see. So there's some like MSVC stuff that's not portable happening here.
Yeah, one of them was like he's using a com function called draw text, and I think it's being Unicode defined into draw text A, but it's a com function, so it shouldn't be doing that. So I think that's a min-GW header issue again.
Interesting.
So anyway, yeah, that's the stuff I'm working on. Kind of interesting.
Pretty cool.
Yeah.
I'm just if you hear me typing, it's because I'm curious now whether min-GW has an update since the last time we checked.
They were at 9.0, right?
Yeah, I think that's the one we're on, and I'm just seeing if there's a new tag or not. Yeah, still on 9.
Yeah.
Well, thank you for sharing. So, by the way, about the Borg issue that you were encountering yesterday, did you end up finding what it was?
Yeah, the issue was one of my the two entries in my resolve.conf file in WSL
Uh-huh.
were like not valid. Those servers weren't responding.
Oh,
And the way that Zig standard library DNS resolver works is it in parallel requests all the servers and then it waits for all the responses, but two of them weren't responding. So it's just stuck waiting
I
for
see.
the responses and there's no timeout. So that,
cancellation.
we need to have a timeout in our
Cancellation's hard.
DNS client. Yeah.
Right. Oh man, async cancellation has been eating my mind lately. Okay, cool. Thank you very much for sharing. Is there anything else you want to say before we move forward?
Can't think of anything.
That works too.
Hey, good to see you. Looking forward to buying you a drink in Seattle.
Nice.
Awesome. We'll see you there.
Awesome. Okay, so next should be, I believe Megan has been waiting for a while now. So let's do Megan and then let's try Ed again if he's available. Megan. Ready, question mark. Mute the stream. Okay, wow.
Do we have a big
Ed's
queue?
ready. Oh,
Oh,
okay. Then let's do Ed. Let's see. Nice. Ready now, question mark. Okay, let's see if Ed can make it work.
we believe in you, Ed. Let's go.
Let's see. Oh man, like that's funny. So the more people we pull in, the more people show up in the waiting room. That's gonna be interesting.
What do you mean?
It's like we're not depleting the pool. The pool is expanding as we pull more people.
Oh, I see. That's funny, right? You think that when we pop one off the queue, then it should get smaller, but it's actually getting bigger.
Yeah, that's actually how it usually works with me and compile errors and bugs in Borg. But I did not expect that to translate also with to people.
That's funny.
Okay, let's start to pull Ed. Let's see how it works. Ed, is this all working for you now?
Hey, I can hear you. It's a bit quiet though.
It's super quiet. I'm trying to pump up your volume, but I don't think that will be enough. Can you try saying something?
Okay, can you guys hear me now?
Oh,
Great.
yes.
Wow.
Hello.
We're cooking.
Are you not hearing me?
Yes, we are.
We're good.
Oh, no,
Great.
we are.
Are you guys hearing me?
Yes.
I think he's not hearing us.
Yeah.
Am I being heard?
Yes, you are.
Discord issues.
Mhm. We got screen, we got audio. We just don't have the other way audio.
Oh no, that's Linux. That's a Linux moment. I'm sorry, but that's how it is. Oh, we can even see you. Oh no.
Yeah, mic is not working.
It is working. Your
guys
mic
don't
is
hear me.
working. Yes, we do. We hear you great. It's the speakers.
It's a problem if you can hear if you cannot hear us though.
Yeah.
We can hear you. It's just that you can hear
That
us.
is the exasperated sigh of someone who is intimately familiar with the workings of a computer and yet.
That's software. Okay, then Megan. Okay, one sec. Okay, let's see. Megan is ready. Cool. Let's go. Hello. Hey, Megan, can you hear us?
You're muted, Megan.
Hello?
Hello.
Hey.
Okay,
Hey, there we go.
how's it going? What are
How
you
we
showing
doing?
us?
I'm good. So I'm going to show a side project that I've been working on lately. So the main thing I've been doing is also converting a Go app into a Zig web app. And I've been publishing a bunch of little accompanying libraries in my GitHub. But I also have like another little side project that I started recently, which was to build a CI that's entirely in Zig.
Oh.
Okay.
And it's a big undertaking, so it's obviously not all the way there, but there's something I can show. So,
Watch out, Source Hut.
no, so the funny thing was that, so like, the inspiration for this project was originally because I eventually wanted to add a CI feature to Aquila, the website that is, like, which is the package index that I run for Zigmod, which presently it's for Zigmod, but later it'll be for the built-in one. And I'd also been talking to Luna, who was running some of this CI infrastructure with SourceHut for Zig with like BSD, and them telling me about like how much of a pain it is. SourceHut does have a really nice design language though, but I hear running it has its difficulties. So this part I'm not going to show off, but I can go over. This is the script that actually generates the OS images. So the general architecture of how this works right now, in its present state, is I wanted it to be like completely OS agnostic, so that like we could test it on multiple platforms and whatnot. So I ended up landing on Kimu, and then so what these like OS scripts do is download the ISO for the respective operating system. This one started with Debian because I'm pretty familiar with Debian, and I wanted to work out like the kinks of the app before I worked out kinks in other operating systems. And then what this section does is unpacks it. It imports this preseed.config file into it, which when you're going through the installer, it'll like prompt you for a bunch of questions. And what this preseed file does is allow you a way to pre-fill answers to all of the questions. So that way, when you run the script, all you have to do is run it, and then it'll just like completely go through the installation with no other user input, which is really nice. And then this will pack it back into an ISO and generate a Kimu image for it. Oh, and then yeah, so this will actually run the installer, and then we have an image on the other side that's like a bootable version of that operating system. And then this is the Zig app in its current state. So we have a couple of commands. Currently grouped by like the main thing of what it does. This sets up a bunch of environment for debugging. This installs all of Zig's dependencies, and then this builds or clones and builds Zig, and then runs the behavior tests at the end. And then this is some little boilerplate to get all that to working. So another thing I didn't mention is part of this pre-seed file that I have over here. It also adds an SSH key into the like host operating system or like container operating system. So that way, when this SSH command runs here, and then inserts like the command from up here, it doesn't ask you for password prompt. which is really nice considering I want this to run like all headlessly. And then what this will do, this will like run the command, capture all the output, and then print it to a nice little HTML file that I can show once this is done. And then this script right here throws it all together, and I can show what that looks like. I would show off the generation script, but that takes a little bit longer, and it kind of messes up your SSH keys. So this will be as smooth as possible. So what this did is it double checked that we selected the operating system and architecture we wanted. It ran the generation script, but the generation script has like a test to see if the base image is already there. So that finished very quickly. And then it runs this command where it sleeps and starts up KVM, which is like a kernel module version of QEMU that like has a lot faster performance for like native targets, which booted up this window, and then now it's running the commands, and we get a little debug output of what it's running and then also how long it takes. So I'm going to give this a little second to run.
So it's doing all that stuff, like kind of like behind the scenes in QEMU.
Yeah, so it logged in to this QEMU window that popped up, and then it's running these commands on this VM.
Cool. I didn't even know QEMU could be
used.
used this way.
Yeah, that's cool. So while it runs, Megan, are you going to be at Handmade Seattle?
Yeah, I'm gonna be up at Seattle next week. I can't believe it's only like 4 days away. I'm really excited.
Yeah.
Oh man.
Are you gonna bring your Zig plushie?
Oh yeah.
Watch out! You gotta keep an eye on that. People might be on the hunt for Zig plushies.
I heard that Abner is like hungry for plushies, so be careful. He's gonna eat it. I'm bringing one to try to appease him, but...
What did you say, Lars?
I'm bringing one to hope I can appease his hunger, but
oh yeah,
I don't know. We'll see.
So you're building Zig right now.
Yep. So right now it's running. So it finished running, like adding all the dependencies for Zig, and then it's currently building it. I wanted this to be like eventually as generic as possible. So right now, like this script does like everything from scratch. If you wanted to make this like specific to project, you could like run all of these dependency things first and then like make a new template image. So that way like new runs would like only run like from git clone down. Yeah, I was double checking this while I was in the waiting room because I previously hadn't updated this to LLVM 13. It was still on 12, and I was like, oh, I gotta fix that before
Yeah, that wouldn't work.
Yeah.
I get on.
So what's the slowdown in QEMU this way?
So yeah, so the performance isn't necessarily as great per se as if you were running it natively, and part of it comes from that when you run it inside a VM, the virtual CPU that's provided only has a single core.
Oh, okay.
Oh, there we go. We are running behavior tests.
Hey.
Nice. And then this takes, when I ran it before I got on, this took just under a minute and a half.
Cool.
Which
So I'm
I
getting.
think
Oh, go ahead. Sorry.
I think it should be faster. Um, but I'm unsure if the majority of that time is spent building it like um, during the build of the behavior tests in a single threaded way, or if it's actually running, or if the majority of the slow part is like the actual running of the behavior tests.
I have a couple questions.
Okay.
So does this mean you would be able to swap out x86 with ARM, for example, or RISC-V, and have the QEMU virtual machine be a different architecture?
Yeah, totally.
Cool. Okay, next question. Would you be able to use Windows as the guest?
Um, like inside the chemo image,
Yeah.
uh, it's on the to-do list.
It works though? I mean, like in theory?
Um, I haven't looked into, because does Windows have SSH?
I mean, they got some kind of something, right? Probably.
If they
Uh,
have, I would probably have to look into making the app support remote desktop.
yeah, I think they have that. I don't think they have. I mean, they have Telnet, but I believe that you don't get like access to. I don't remember. Like the show situation in Windows is abysmal.
Well, I mean,
I
Azure does it
definitely,
somehow, right?
so the goal of this project was to like obviously get a CI working. Um, but I also ran into like something that I found really shocking when I was doing like the research for this. Was because I was wondering, I was trying to figure out like when I was trying to decide on like what program to use like as a virtual machine, um, whether that be QEMU or Docker. Like Docker got thrown out very early on because like Docker is tied to Linux, and I wanted this to support like many different operating systems. And I was trying to figure out, I was like, so I knew that like say GitHub Actions or GitLab or Drone like have support for other operating systems, and I was like, oh, how do those work? Because in my head I was thinking, well, you wouldn't want to like log into another host machine and then just let it run because like if say you were only running this on like master, then that would be fine because you have total control over like all the code that makes it into your repository. But if you are also enabling CI on pull requests, then like you don't necessarily like have as much control over like people can change the CI code. GitHub Actions kind of gets around this because you have to approve um, like new contributors. Um, but then it also becomes like a very binary thing. I was like how are they containerizing this in a way so that like people don't access other parts of the system? Um, and I found out that like on Linux and stuff, or BSD, like they can use like C groups or jails and whatnot. And I was like, on Windows, they to some degree they just don't. um, so I think what something like GitHub Actions does is no, wait, that's not.
Well, if they're spinning up a new instance for each job, that sounds inefficient, but at the same time, hey, it increases cloud consumption, so
Mm.
it
Yeah.
checks all, like, helps bring up all the KPIs. I'm sure the manager who came up with that idea got a raise. uh, Okay. So how's are those tests going? Would be nice if there have like also some kind of progress. Unfortunately.
Yeah, I want to get the output to print like in the. Okay, so I can actually minimize this real quick. So something that I haven't figured out how to do is, or haven't added to this, was down where it's actually running the commands, it will grab the reader from standard out and standard error, and I didn't know how to combine them into a single reader such that like actually Marler probably had to figure this out for the terminal, but I was like, as a terminal, like how do you multiplex the two streams?
Yeah, it's really tricky to get right. So you're trying to both display it and capture it here, is that correct?
Well, no, so it's not displaying it right now. It does capture it though.
Yeah. By the way, there's a problem here. I think we want to change the API to make the problem less easy to trigger on accident. But so if you read standard out to the end and then standard error to the end, you could get a deadlock if the program fills the standard error buffer before before doing a standard out right. Because standard out reading will block, and then on the parent process, and then in the child process, writing to standard error will block. That's a deadlock. I think we have a way to get it. I think Lemon Boy solved this problem, and there's an API you can use that will use like pull or something, and it'll just grab all the output for you.
That would be great. For some of the commands, having them separated is nice, but generally speaking, I would want them combined. When I ran this before, the first one took like 100 seconds, but I think it's been a bit longer than that. So we can see. Sometimes this takes like a lot longer than it should. Oh, actually,
Yeah, it worked now.
let's
Took
see
a
how
while.
far it gets. So it outputs to this HTML file, which I can show here.
Oh, cool.
And then you can see the command output of.
Oh, I see. So you were with those arrays, you were simulating like a build configure, like CI script configure, like pipeline configuration.
Yeah.
Ah, yeah. Okay. Cool.
And then so we can see down here. Yeah. So it succeeded. Let's see how
Nice.
far it made it down.
Oh, did you kill it?
Yeah, I killed it.
Got it.
Oh,
The last one did finish, but I think I killed it before stage 2 finished.
You know, also
Yeah.
what's probably not helping, your screen sharing with Discord. That's another thing that that consumes resources.
Oh, this one didn't finish either. Yeah, for some reason, like actually, like everything from here up runs at a pretty decent speed, but then
Hey.
like the actual compiled program ends up running like what seems to be a lot slower than native performance.
Those behavior tests run really fast. I suspect it could be that deadlock issue.
Yeah.
After you go off the stream, take a look in the child process API and see if there's, I think you can call like exec or exec2 or something like that, and it'll just do all that work for you, and it will avoid the deadlock problem.
Oh, you're trying to run those tests on the host machine?
Yeah, because on the host it takes like a couple seconds, like maybe. And this is with stage 1, it takes 8 seconds.
Yeah. Yeah, then I guess Andrew might be onto something. Is there anything else that you want to show us?
I think that was all for now.
Okay. Awesome. Anything you want to say before we move forward?
Yeah, Andrew already asked, but I'll see y'all at Handmade Seattle.
Yeah, see you
Okay.
there.
Awesome. Thank you,
Thanks for
Megan.
doing this, Lawrence.
No problem. Thank you for coming. Okay. Now let's see. Okay, we have Felix. I think Felix is probably itching to show us something cool. Let's do Felix. New radio shows. Okay, so we have also a new face, which is nice. Okay, then we have Ali and Guillaume Wenzek. Awesome. Oh, we also have some. Guillaume has given a talk a while ago, but it's been a while since we've seen him. So looking forward. Okay, let's do Felix. Ready, mute stream.
We haven't had any mute stream accidents so far today.
Oh yeah. Oh, because I'm vigilant every single time. I'm the mute stream police. Hey Felix, how's it going?
Hello.
Hello.
Yeah, so today I'm going to showcase the game I'm working on right now.
Okay.
And yeah, let me just get up the screen share. So yeah, let me just check if it will appear in the screen.
It works. We see it. Digital
Okay,
scavenger.
perfect. Yeah, exactly. So the game is basically you play a young me, like literally me, a person who discovers the world of computers and like how awesome everything is. And the game tries to like imagine how a world would be if you can hack everything.
Okay.
Like there's a door and the door is controlled by a computer, obviously, that will trigger if you go to the door and like press a knob and the door will go open and you can hack like the computer controlling this and for example check if, hey, that's a NPC I don't like, that NPC can't use the door right now because I can do a name check and just like say if name is not NPC name I want, don't open the door.
Mm-hmm.
And the game is meant to be like an open world game where you can do puzzles and go around with a boat. That's because you can see the water here. You will drive in like a huge landscape filled with water, and there will be a lot of small islands you can discover. And
It's like you're a pirate.
Kinda, yeah. Like a hacking pirate. So, yeah, the game is kinda built on the mental basis of Zig Showdown and uses the same concepts. So I have scenes. This right now is the splash screen scene. And if I click, I'm going to do a transition to the main menu. And you can see we have like this smooth sliding animation. And like updating of the game loop of the splash screen scene is stopped, but the rendering will continue and you can see animations and everything. So I have shared this before, where you have like a boat and we can drive around and see wonderful islands. We have a very flat island and you can see here in a bit of green the outlines of the islands, and these outlines get automatically derived from the mesh. So if I'm going to crash into the island, I will have a collision, which is done by Box2D, which is a C++ library. Luckily, you can build it by just dropping in all C++ files and you just build it and it will work. There's zero configuration needed. This was very convenient. So yeah, and they can collide perfectly on the water line. And I'm going to show this. So the water surface here is endless, so I can go into any direction as long as I want, and there will never be like repeating patterns or like the end of the water mesh.
Oh, the islands are procedurally generated?
No, there's only these 4 islands right now.
Oh, it wraps.
No, you can just go into the wild and there will be nothing. It will
Oh,
be
I see. I
endless.
see. Okay.
So this one here is an island made by my artist, friend of mine, is joining me in the game. And we have these docking stations where you can like go into the circle, press space, and you will enter the island. And as you can see, well, all the other islands are gone because we changed the scene. And yeah, I will do the rendering of the rest of the scenes later, but this is for changing the rendering context to something where I can render the island in high res and all the other islands in low res, so LOD techniques. So I can go back with escape and go back to the scene with the boat, but let's explore the island for a bit. So you can see we have these red and green polygons on the ground, and I'm using these for movement. So normally you use like a polygon mesh to collide with everything, and I didn't want to like use a complete 3D physics engine because it's super hard to get like a player right with it. And my idea was to implement a navigation mesh. So this is just a surface mesh where every walkable polygon in the scene is a polygon in the mesh, or like a node in the mesh. And you can see this green triangle, which is this one here. This is the triangle I'm currently on. This is player polygon 27. And if I'm moving to the polygon here, you can see the polygon index changes. And I'm always drawing the 3 adjacent polygons if possible. So I cannot leave the island through this edge, but I can walk around this because these polygons are not included in the nav mesh, but the polygons around here are. And yeah. So this is all the tech for the 2D movement, like on the water and on the islands. Everything is implemented in 2D, so there's no fancy 3D math, but everything is simple. And the cool thing is, this nav mesh implementation can do overlapping 2D polygons. So we can walk around here, and we can follow our dirt track into a tunnel below.
Ooh, what's in here?
It's just a boring tunnel through the island. But the cool thing is, we can walk on these polygons below and the polygons above. I cannot walk up here, it's too steep.
Very smooth.
Yeah. Can walk here, and yeah, this is pretty neat because everything is still 2D, even if it overlaps. So I can do bridges, I can do tunnels, I can do every walkable geometry we need in a game. Yeah, and this is what I have for the 3D gameplay right now. But there's also a different thing I can showcase, which is hidden in the credits menu. And this is this thing here. It's, as I said, this game is about hacking, and what we have here is we have a computer terminal, and we can turn this computer off, we can turn it on, and we can reset it. Oh, and we can also flush the console to start it out, so we get a dump here for debugging. And what we see here is a computer runs Lola code, which is the programming language I did in Zig. And we can have a pretty primitive editor below here, where we can edit the code. So if I'm going in here and say print hello showtime, and we reset the computer, we get a hello showtime. And
fun.
you can see there's a CPU utilization, as we need to somehow control how many CPU cycles the player can use, not only for like balancing, but also we're running on a real computer that isn't infinitely powerful, so we have to constrain the simulation. And what you can see here is Lola has the abilities to suspend code and run only for like a certain amount of instructions. And this is the hot loop. This is this while loop here, which just busy idles 5 seconds. The cold loop is just a call to sleep, which waits for 5 seconds. And we have the semi-cold loop, which is also a busy loop, which waits 5 seconds. But it calls yield, which means I'm done for this frame. Please give up any rest of the computing power I have. I'm done for now. Save power, not cycles. And I'm doing some busy work here. So we get CPU utilization. And if I'm resetting it, you can see that if you go in the hot loop, it will take up all cycles we have. And the cold loop will take 0 CPU time. And this range 100 iteration takes 20% of the CPU.
Oh, I see. Cool.
Mm-hmm. Pretty cool.
Yeah. And right now, I'm working on a pretty cool thing. There is an editor called Skite. It looks like this. Some of you may know it. And the cool thing about Skite is that Skite is actually like the Scintilla text editor. And Scintilla is a text editor widget for like code editing. And it is completely written in C++ and also like drop-in. And this is what it looks right now. So this is an integration of Scintilla into my game. As you can see, it doesn't render text, but it recognizes the right characters. So we have the outline of the code is right. So I have no idea why it doesn't render text. Would have been cool to showcase this, but yeah. This is the next thing, to get like a good text editing widget, because this game is about coding, and yeah, we need a good code editor. Everyone knows this.
Right.
But yeah, that's what I'm working on.
Makes sense that you need a code editor in a hacking game. Cool.
This is exciting.
So Felix, I have a question. What's the state of Zig Showdown?
Please don't ask.
Okay, then is there anything else that you want to say before we move forward and try to forget about Zig Showdown?
Yeah, sure. Use Zero graphics. It's really good. It's the base of this game, and I'm constantly improving it.
Do you want to pull up the GitHub page so that people can see?
Oh, yeah, I can do.
Oh yeah, the paintbrush one. That's funny.
Yeah, it currently runs on desktop, WebAssembly, and Android.
Cool.
And it also you can build from any platform to any of these platforms. And it has an integrated UI system. You've seen this in the menu. And it has an integrated 3D renderer. You've seen this in the 3D scenes. And maybe it even gets an integrated text editor, which is built on Scintilla.
Wow.
And the coolest thing I can show off is we can go into a new directory, and instead of Zig init, use 0 init, which will help you set up a new project. And we can use the symlink here, because submodule cloning takes too long. And then we can do zig build run. It'll take a minute or so. And build script, application.
What dependencies is it compiling?
A lot.
Okay.
And we have a new project. We can... I think we can even compile it to the web. Check out. Does it have a web target? No. But Zero Graphics also ships the awesome HTTP server by Luke.
Mm-hmm.
And you can do, on most projects, you can do just Zig build run web, and you get a HTTP link you can click and just use it on the web platform.
Cool.
This will look like Zig build run web. Oh no.
Oh man, can't wait
Updating
till
Zig. Yeah,
can't wait till we get that new compiler coming faster.
Yeah. Oh no! Is it around WASM? Oh, yeah. Yeah, stage 2 is definitely awaited by me. Like, I'm really hyped for better build times.
Yeah. I don't know if you saw, but even the LLVM backend is twice as fast as the
Yeah, this
with
is
stage
really
2.
nice. So yeah, we just get a link and we can go to the browser and see the demo application and play around with it.
Very cool. So the same code base can work in the browser and on Android and on the desktop.
Yeah, exactly.
Wow.
Pretty cool. Yeah, looking forward to
that's it.
seeing people doing multi-platform applications like this. Thank you very much, Felix.
You're welcome.
Okay, then let's move forward. Let's see who's next. Let me move Phoenix. And let's pull in. I think we should pull in Ali. He's probably been waiting for a while now. So ready, ? Mute stream.
Loris, do I have time for a very short potty break?
Oh yeah.
Okay. I'll be right back.
Let's go. Yeah, sorry. I forget that other people have like normal human being needs. As a host, I'm used to just stay on stream as long as it takes. We are not having a break though. That is true. I think the Zig RUSH format needs still a little bit of work. I think it's a neat idea, but it needs a little bit of work still. In any case, let's start pulling in Ali, and let's also hope that Andrew comes back right on time. Hey Ali, can you hear me?
Hello.
Hello. Okay, so we are waiting for Andrew to come, but in the meantime, if you want, you can start telling us what you plan to show.
Okay. Can you see that?
Yeah, let me check. I see blackness. I see your mouse, but other than that, I see blackness. Is that correct?
That will be byline problem. Sorry, can you move me and I can check the problem?
Okay. Yeah, that's Wayland problems. I can see that happening. Okay. Then I'll move you back. Talk to you later. Okay. So Ali was having video issues, and so let's have new radio shows come, and then let's see if Guillaume wants to bring us to a closer to the show end. So new radio shows. Oh wait. Okay. Okay. Let's okay. Ready now? Let's have Guillaume then. He just asked me that to go now, so that's fine. Let's do Guillaume and then new radio. Okay. Hello. Can you hear us?
Okay.
Hey. Yeah.
You are just Cheng.
Perfect.
Okay, hello.
Hello. We can also see you. Nice.
Great.
Okay, what are you showing us?
You can see my screen too?
Yes.
Okay, and I need to mute the stream. Yes. Okay, good. Great. So should I start?
Yes, we are. I think we're hearing something in the background.
I think I have a pretty bad mic. I can try to maybe lower. Yes, my microphone is pretty bad. I'm sorry.
Okay, let's go with this. I think this is okay. Okay, please go.
Okay. Okay, so this demo is about GPU programming. So I've been taking this class, like I wanted to learn more about GPU, and I took a class on Udacity, and it's using CUDA. So it's programming only on NVIDIA GPUs. And like here is like the code for the first exercise where you have to convert an image from RGB to gray. And so CUDA program are structured like this. So you have a function which is meant to be executed on the GPU, and you have rest of the code which is coding the function. So this is code from the CPU, and it's like piloting driving the GPU. So as you can see, it looks like C. It's actually some kind of C++, but you have a bunch of built-ins, like you have some variables like block ID that tells like the GPU thread, like what is the current thread ID and what part of the memory it should operate on. And you also have like special syntax to when you want to call a function on the GPU. And all this is compiled using like NVIDIA proprietary compiler, NVCC. And like this is only the first exercise, so it's pretty simple, but this goes on like you write more and more complex tasks, and there's more and more synchronization between the two. And like I wanted to use something else and some kind of C++, so I wanted to try to see how much of this I could write in Zig. So the first thing I did was to split this code into two parts. I will keep the GPU code, the kernel in CUDA. So this is like something like C. I will only use like a C subset of the language supported by NVCC. And in Zig, since this is C, I can like C import it using Zig, and I can like have access to this function in my Zig code. And now my Zig code is aware of like what is the signature of the function, and I can call it inside Zig using like CUDA C API. So here I'm importing, I'm using basically the CUDA API, the C API, which is relatively easy to work with. And how this works is because like behind the scenes, NVIDIA is having some kind of assembly. So the compiler is generating some kind of assembly like this. So here you have my function with the parameters, and like put stuff in registers, like to, it's some kind of assembly. And you can ask CUDA, you can ask the GPU to load this assembly file, optimize it for the specific version of the GPU you are using, and then you can launch this function from using the CUDA API. And so here I have my bootloader, which is compiling the CUDA file to PTX assembly format using NVCC compiler, and I'm calling it from Zig. But I wanted to go a step further, and I wanted to be able to write like the CUDA code in Zig too. So I've been asking questions around in Discord, and Snectron give me several hints, and so the goal, maybe just first I'll just see that it works. So just to show you what this code is doing, it's taking this image and it's computing a grayscale version. And so I wanted to be able to write my kernel in Zig. So here is the kernel I wrote in Zig, and I will need to go to the build Zig. And here I would just do add Zig homework instead. And also need to change a bit my Zig calling code because now it's a bit different. And here, as you can see, I'm not passing any more C pointers to my kernel. I'm passing actually slices of bytes. And voila, I have the new version. I mean, the same image, of course. So how does it work? So here I'm using stage 2. I modified a bit stage 2 compiler to be able to ask the stage 2 compiler to be able to output himself this PTX version. So this is the one generated by stage 2. So I'm a bit more limited by the features that stage 2 supports. For example, there was, at the time I compiled this, there was no support from float to int conversion, so that's why I'm doing all the operation in integers and not as floats. And I'm also doing a bit of hacky stuff, like here, to be able to read a special register, like to know what is the thread ID. I'm just passing inline assembly through the various stages. And yeah, so that's how I managed to do like general programming on the GPU using Zig.
Wow.
Very cool.
It's very beginning. Like it started working on like Wednesday this week. So I mean, this is only like the first homework, just doing grayscale conversion. But really want to see how far I can push this. The upcoming exercises are more interesting. Like you have to implement a sort algorithm on the GPU. If I could do this in Zig, it would be nice.
It would be very interesting to know if the standard library sort function works or not.
Yeah, the stuff like that. I also want to try like the library hash map because like typically when you code in GPU, you're only using very basic data structures. But since we have, so I need to write like an allocator for the GPU. It's not, so I basically need to wrap like the CUDA primitives to allocate memory inside like a standard allocator API for Zig, and try to see if I can use all these built-in data structures and sorting and so on.
Very cool. You could also try using the fixed buffer allocator on a array of bytes.
Yeah, totally. That's a good point.
Yeah, that's very interesting. So you're able to use stage 2. That's super bleeding edge. So it's not
Wait,
just
is that right?
Zig.
Oh, I missed that.
Oh, you missed that. Yeah, he was able to output to write Zig code, then becomes the code run by the CUDA kernel. Yeah.
Oh, you're using the self-hosted backend. Oh. Okay.
Yeah. So basically, I have a branch of Zig where it's not many changes, but I think I created. No, I don't think I haven't committed anything. I'm not sure. Yeah. I just created a new. Basically, I just want to say, like when you call LLVM on the Zig IR, I just want to say output the assembly for the PTX targets, NVIDIA PTX targets. So I just have to modify a bit how it works there, and then I'm able to load this PTX in Zig. And that's a nice thing too, that now I can pass slices. So I can use the slices. And that's actually very recent, because when I first make it work, like slices were not working in stage 2, and like now they work, so I can.
That's very cool. You should write a blog post about this stuff. Just saying.
Yeah, so I'm actually pretty excited to see how far this can go. I mean, I'm probably sure I will have to wait a bit more for stage 2 to progress, but I also see that the progress is very impressive and ongoing. So, and also this class is, I mean, the algorithm are not very so complicated. It's very like a lot of arithmetic sorting. I'm pretty sure maybe not too hard for the backend. I mean, in the long term, we could envisage to have to not use LLVM at all, because I mean, this PTX is really is assembly, but it's also very high level in a sense, because you have functions, you have a lot of stuff, which I mean, it's not too hard. I know that Nocturne is going a bit in this direction with the what's called SPIR-V standard. And also there's also a lot of stuff I would like to be able to do. I think typically there's different memory region. Some of the kernel functions, they can use memory region which is specific to where the current thread is. So in a GPU, you have threads running block by block, and like threads in the same block, they can share memory. using like very fast memory, and they don't have to go to the global memory to share information with other threads. So I would like to be able to use these different memory region in my Zig code. But so far, it's yeah, just an idea.
Yeah, Robin did that initial work for that.
Yeah.
And I know that I regressed it a little bit with some of the recent LLVM backend progress, but we'll go make sure and restore that functionality.
Yeah, I mean, it's work in progress and it's also very bleeding edge. So I'm not expecting any kind of stability, but yeah, I like to see how it looks like ergonomic wise, like how, because like in classic CUDA code, all the pointers are regular pointers, so it's easy to mix up host pointers, pointer to host memory and pointer to device memory. So typically people they use naming convention, but yeah, if you could have a type system, it would be, I think, would be like a killer feature. So yeah.
Very
And
cool.
yeah, also I may need some help, like in my build.zig is really not that clean. Yeah, I can show you. I think the worst thing is I'm using Z here to fix up the assembly. But beyond that, yeah, I need to yeah, there's also a bunch of cleanup I need to do. I need to understand better how how Zig talks with LLVM, so I can add the proper annotation without having to use this kind of hack. But yeah.
Oh, by the way, if you didn't know, there is a flag to emit assembly, which might allow you to not have to have your fork f emit ASM.
Yeah, I need to look into that. I'm not sure how. Yeah, there's probably a lot of stuff like which are not needed that I did. So yeah, yeah. If
Maybe
someone has more expert,
sorry.
Cool.
Maybe sometime in the next couple months, if you like, we can do a meeting and you can just go over your project and all of the parts where it's awkward or confusing or hacky, and we can try and translate that into fixes upstream. How does that sound?
Okay, sounds good.
Yeah.
Yeah.
Cool.
Okay. I'll be honored.
Awesome. Is there anything else you want to say before we move forward?
Yeah, no, I'm good. Thanks for having me. And yeah, I enjoyed the show so far. Really love this format.
Thank you very much.
Yeah. Thanks.
It's been a pleasure having you here. Hope to see more from you soon. Yeah. So bye bye.
Okay. Bye. Thanks.
Bye bye.
Okay, so we have two more people. We have GNU Radio Shows and Ed. Let's do GNU Radio Shows, and then let's see if we can end it with a bang with Ed. Who?
Come on, Ed. I believe in your ability to get
I think
your
we can make
computer
it.
working.
So, okay, let's do GNU Radio Shows. Message. Hello. Are you ready? Also mute this way. Yes, we have signal. Let's go.
Main screen, turn on.
Hello. Just so you know, you're muted. So you'll need to unmute yourself.
Can you hear me now?
Yes,
Hello.
we can. Hello.
I'll share my screen. Do I have to not be in full screen? Is it just not going to work? Huh?
If you haven't used Discord that much before, I recommend the when it asks you to pick a window, pick the full desktop.
Are you on Linux also?
Share
Oh,
screen.
no.
Oh, that's not. Let's try this again.
That never helps.
All right, here we go.
Oh.
Oh, now I have to approve it. Sorry, this might.
Wait, if you have to prove it, is that then a Mac machine? Oh, macOS, you
All
have to
right,
approve
sorry.
it the first time.
It says I have to restart Firefox, so just give me like a few minutes. You can let the other person go.
Okay. Okay, so let's see if Ed is available.
Come on, Ed, you got this.
Or let's see. Oh, it's a Mac. Okay. Also, wait, I think like new radio shows might not have been able to hear us on stream. Okay, people, we need to step up the ability to work with Discord though. This is I need to write a guide about this. So let's see. Ed, are you available now? Yep, we need to step up the stats and everything else. I gave a chance to everybody to come in my voice channel and do a audio video test before the show. And I think next time I'm going to remind everybody how important it is. It helps a lot. I mean, it's not a big deal if we have the show that's like a little bit janky, right? We're not like high quality production, TV, whatever. But I can understand that it feels stressful to people when they're trying to do stuff and it doesn't work in their life, and there's a bunch of people watching them.
Yeah, makes sense.
So Ed is screen sharing in the other room. Okay, let's see. Oh, okay, so he's ready. Let's go. Hello, Ed. Can you hear us?
Yes, I can hear you.
Nice. And we can hear you. Nice. You're a bit low, but we can hear you.
Now.
By the way, earlier you had a perfect mic volume.
Yeah, earlier you couldn't hear us, but we could hear you perfectly. Oh, did it happen again?
Okay, we have screen share.
Okay, so basically, I've been working.
Ed, you're very, very low. We cannot hear you.
Okay, let me see if I can do something.
One thing that you could double check is if Discord is using the right microphone device, for example. That's one thing. If you need some more time, we can try to do. Oh, yes.
Ooh.
Yeah, bump it up to 100%. Let's go.
Okay.
No, to the max, 100%, please.
Are you hearing me okay?
Yeah, but I have to put you very high in my Discord. Like, if you can, yeah, let's go. Oh, yes, that's so nice. Thank you.
I don't know. Before it was auto. The auto was working. Now it doesn't seem to be. Any case.
Now you sound great. We are a go.
Okay, finally. I've been in computing for ages. As it stands right now, to give you a perspective that's totally different, my daughter is currently in labor.
Oh, wow.
Yeah.
So that must be exciting.
It's very exciting. But any case, so I've been around computers for a while. I have a very different background from most of you. I've come up on the practical side. My university, which I never finished, was over 40 years ago. So when you talk AST Gen and all this, I know vaguely what you're talking about, but it's gray because I haven't had to use that in 40 years. So, any case, there are a couple tools that I've come across over the years that I've really liked, and one of them is called pipes, which is what I want to talk about here. Now, pipes is originally implemented in an interpreted language that's untyped, or rather it has one type called a rex type, which is basically a string which you can do computations on, you can parse, you can do all sorts of stuff with it. Zig doesn't work that way. So what I started off with here is let's define a pipe that is going to have filters. Each filter, by the way, you can think of as it's a Zig async function, basically. So I basically said here, I've got a filter and I want it to be able to pass U64s, arrays of U64s, or an array list of U64s. And by default, it expects a U64. I couldn't use unions or anything in this. They weren't flexible enough for what I needed, so I had to create it with a type union, which is what I'm using here. Basically, you go through the types, you figure out the alignments of them, you figure out how much space they need, you allocate the storage, and use pointer cast to move things around. So once you've got that in, you then have to tell the filters what type that you basically have to tie the filters to one of these. You basically have to tell the filters, which are all generic functions, what type union you're using, so that you're able to pass values through them, and you're able to start them as async functions because you can't async a generic function. You can't call it with async call. So in any case, once you've got all that done, you can actually define a pipe. Now, pipes are basically just directed graphs. So here I'm saying let's generate some numbers up to a value AAA, and that AAA is actually determined when you run the pipe, not when the tuple is defined. And it's just something that's up here inside a little struct. And I just use that so I can just pick out a context. In any case, I generate numbers. If they exactly divide by the value in XXX, they go out on the primary stream. And fan in any basic, one thing that's different from a pipe here, just think of a pipe in your house. You can connect them in all sorts of strange ways. So what's happening here is I'm just taking the output of the exact div. If it works, it goes directly down to fan in any. If it doesn't exactly divide, it goes down here and tries seeing, does it divide by 7? If that works, it goes to B, which goes back up to the fan in any. Fan in any just sort of combines. It's like, think of it as 3 or 4 pipes coming together into one pipe. I can see puzzlement on faces there, so I'm not quite clear.
It's intrigue. Yeah, keep going.
Yeah. So basically, it's just mixing all the inputs together here, and then I just output the consoles. But anyhow, that's basically the idea of it here. The thing that I liked about Zig is Zig has async functions, and async functions are the ideal way to implement this. Because what will happen is there's a little dispatcher in there that sits there going through and doing various things to make sure everything runs in the right order. I know I'm not being the world's most lucid here.
No, you're good. I think it's going to make more and more sense the more we get down in the file.
Let's look at something very, very simple, like here. So here I'm just generating a bunch of numbers up to the value of test me. And test me is just a variable, and I'm just outputting them to the console. One that might be a bit more interesting is here. What I'm doing here is I'm creating an array with a U64 type union, array of type unions, with the value of the first entry a U64, the second being a slice, and the third being an array list. So now I've got an array or a slice basically of items, type unions of different types. So right here, I'm just taking list and sticking it into the pipeline. What Colite types does is it takes the elements that are in the slice and puts them out on different streams depending on their type. So the first stream will have U64s, the second stream will have my slices, and the third stream will have the array list. So, and then I have the same thing with the fan and any here, where the outputs of all whatever I'm doing with each of these different types gets combined, and then that gets shoved out to a console. So here, I read a slice, and I output the values of the slice. In this case, I read the array list, and I output the values of the array list. Just to give you an idea what happens, unfortunately, I haven't set it up for everything, but you can see at the bottom here, it just does everything in there. There's a little bit more in there because I'm in the process of getting things of adding some more features. Just to give you an idea how it works, I'll go look at some of the filters. By the way, there is a README with this which takes you through it step by step. But I figure if you're interested, look at the README, it'll help. So if I look over here, this is the Colite type function. Now you may have noticed in here, there's a bunch of numbers in there like right here. And those are actually from 0 to 15. Those are happening because inside the filter, there is another pipe. And right now that pipe doesn't do anything except output to the console. The next thing I've got to do is, instead of a console there, is I want to output that into the pipe that's called. So you could do something like read a file, do whatever you want in there, pass it into the pipeline, and then do whatever you need to do with it.
Can I ask a question?
Most definitely.
At what point would you? What's an example use case where you think, okay, I don't want to write code, it's top down right now. I need to use pipes. What's an example when you would want to do this?
A couple months ago, you were streaming something where you were parsing, I think it was a JSON file, or you were parsing something to create a bunch of files or create a bunch of entries. That's the type of thing that you could use this for very, very easily. Once you have the various filters. Right now, this thing is simply prototype. The filters are in there as I need to test things. Once I get the core of the thing working a little bit more, then I'll be able to start adding some of the real filters. Mind you, what existed in the original CMS pipelines, which is where the idea of this came from, because of the way, basically an untyped language or a single typed language works, the filters won't translate one-to-one. So I'm going to have to go through and look at them. Like one of the filters that you can come up with is sort, and I'll tie that into Zig sort at some point. But you can use.
Sorry, go ahead.
Go.
Oh, so do I understand correctly? Would you say it's similar to the way you can use a regular expression to parse a input string? You could use these pipes on I don't know, more sophisticated input, but
yeah.
in a similar fashion as one might use a regular expression. Is that fair to say?
That's one use case.
Okay.
In CMS pipelines, there are web servers defined as pipes because you can have a connection to outside. The filter that reads a connection does something, dispatches it in there, and you can do load sharing because you can control how many connections you're letting the pipe process and things like this. Right now, everything is done in one thread, but there's no reason that I couldn't do it in multiple threads. I actually did something very similar to this in Java at one point, but unfortunately Java threading model makes pipes really tricky. The async functions are a much better way to do it.
Yeah, Java doesn't have coroutines, right? They're working on it.
No, they don't have coroutines. You end up using a thread per filter, and it's not fun to make it work. Any case, if you are curious about how comp times works, how async functions work, take a look at the source on this. It's up on it's in GitHub under EDTXXX or EDTXX, I think it is. And
Do you want to pull it up on your screen so people have a little visual reminder?
You can also send the link in chat if you want.
Yeah, I just...
You don't have to. I was just a suggestion.
No problem. I quite agree with you. And so there you can see the README.
Oh, nice. You have kind of an intro to pipes there. That's nice.
Yeah. I had somebody ask me for one time when I posted it on one of Christoph's various on his forums.
Okay, so I think I get the idea. So when Andrew was, and also I think I remember which stream you were referring to. I think it was when Andrew was messing with the JSON data from LLVM about architectures, because then you could feed that information, like you could have a filter that parses the outer level of the JSON file and then dispatches stuff based on rules and does processing.
Exactly. And that's the type of thing pipe excels at. I can remember one time, it was I guess it worked much faster than other methods of doing things, which is why I really liked it. And you could also use it directly from the command line in CMS, which was handy. That's something I haven't even thought about how I'm going to do with Zig just yet. Right now, I just want to get the core of it working. There's a function called call pipe, which is the thing I've started doing. And then once you have call pipe working, there's something called add pipe, which basically allows you to dynamically change a pipe. So in other words, you'd be adding different stages dynamically and making them part of the original pipe. Right now, as I say, this is just in its infancy. And, if there's a bug in comp time, I probably hit it.
Yeah, sorry about that.
I was warned.
Yeah.
And I had one good thing about the Zig community is when you post a question, you usually get an answer. And I've had a lot of very good answers from people right from the beginning. Like how to use tuples, how to get async and tuples to work, how comp time works, things that don't work in comp time. So I've had a lot of help with this. So I really appreciate all of that. Any case, I just want to let people see what I've been doing, and as it is now, it's not very useful. Give it a year from now, it probably will be.
Awesome. Well,
thanks for the demo.
Yeah, thank you very much for sharing, Ed. Is there anything else you want to say before we move forward?
Not at this point, no. Thank you.
Okay, awesome. Well, thank to you. Then
Take care, Ed.
Let's have new radio shows and let's conclude the show like this then. Awesome. Thank you very much.
Welcome.
Okay, let's go to GNU. Where's GNU? Ready? Question mark. Oh, there was also Ali. How's it? Okay. GNU is ready. Hello.
All right, and I know for a fact that screen sharing should work now. Hello.
Hello. Oh, wait a second. You're hearing us through the stream, are you?
All right, can you see my screen?
Yes.
Yes.
Here we go. Can you guys hear me?
Yes, we can hear you, but are you listening to us through Discord or through the stream?
Yeah, I can hear you now. I muted the stream.
Okay.
Cool.
Okay, so what I wanted to talk about was just a few building blocks I have for a just-in-time compiler, which is written in Zig. The language this is compiling it's called CJAM. There already is a Java implementation of CJAM, but it kind of has a slow startup time. So I thought I would maybe learn a little about x86, learn a little about compilers, and try to make a practical implementation of the language. Although the language itself is not very practical, because there's a few things about CJAM. It's dynamically typed. It's stack-based like Forth, and it's designed to let you write very very compact code. So in that sense, it's a lot like APL, where the overall philosophy of kind of providing a bunch of very versatile functions that combine together is a lot like APL, although the specifics are quite different. But as a result of kind of the way the language works, a lot of CJAM code can just be compiled as a linear sequence of calls to kind of predefined functions. Not everything, but a lot of the language can be compiled that way. So that works. It works kind of similarly to V8, the JavaScript engine. It has a compiler which I think is called Sparkplug, which is designed to have not do that much optimization and have a pretty fast startup time and that just calls into a bunch of existing built-in functions. So as a result, you can make a just-in-time compiler for a pretty basic subset of it pretty quickly. Oh yeah, this is just an example of CJAM code. It does a little like markdown to HTML conversion, and it's like 148 characters.
Oh god!
So it's
Wow.
kind of yeah, it's not.
I feel
not the most
like I'm
readable thing in the world.
I feel like I'm playing NetHack right now.
It makes you miss Perl a little bit. Sorry, I'm joking, but that's cool. They're very obscure, but they're cool. These type of languages.
Yeah. And I mean, once you use it a little, you start to kind of understand the idioms, and it makes a little more sense.
Yeah, right. You don't see the code anymore, right? You see the metrics.
But anyway, this is kind of the basic framework for how you can do just-in-time compilation. So we have, in this toy language, we have a function called A, which just prints A, and a function called B, which prints B. And we can compile that by creating a memory map, which is defined to be writable, and then you can write things, you write the code to it, and then you use mprotect to make it executable, and then you can just jump to it. One thing about this is that because on x86 you can only have relative jumps that are 32-bit, you need to make sure that the place where you allocate the memory to write the code is within 2 gigabytes away from the functions that you're calling. And since the functions you're calling are generally at the bottom of the address space, the reason I use mmap rather than any allocator is that I specifically pass a flag to mmap to allocate within the first 4 gigabytes of the address space. So yeah, you can get something pretty simple here. And one of the problems with this is that I've annotated these built-in functions as having the C calling convention. And the problem with that is, well, it makes sense for this case because all these are doing is just printing to standard out, and that you don't really need. It's pretty unlikely that the Zig calling convention will change how it works to call a function which doesn't return anything and takes no arguments, but I thought I'd just use C calling convention to be safe. But the problem with this is that in general, because there's a stack, we aren't just going to have these be taking no arguments. We want them to be reading at the very least the data stack pointer, probably some other state. And ideally, we'd store that in registers rather than global variables. So in order to do that, you want to use the same register kind of as the input and the output. And that's not something that you do with the default calling convention. So instead, you can use the naked calling convention. And we're using to read from, so here we have the stack pointer stored in RAX. To read from RAX, we do an assembly block which does nothing, and then we declare that it returns its value in RAX, and that's just a pointer to an unknown number of view sizes. And then we read the top one, increment the stack pointer, and that effectively just adds the top 2 stack elements together. And then we write it back by using the same trick. You have assembly that does nothing, and you say that it takes an argument stored in RAX. And the LLVM's register allocator is smart enough to just turn that into the optimal assembly in this case. So we can do something like this, but it's a little inconvenient to have to kind of put this before and after every built-in that we write. So instead, you can kind of pull it out into its own function called make built-in, which we have a stack kind of struct, which has pop and push functions, and then you have a make built-in function, which creates this naked calling convention function that calls its argument with this fake kind of data structure that we've created to represent the stack. And
that's neat.
Again, the optimizer is smart enough to turn that into the optimal code in every case. So the actual struct that you're creating and passing a pointer to ends up getting inlined away.
Oh, so you basically invented a userland way to define a different calling convention.
Yeah, kind of. And one of the reason this works is something that I'm not even sure if it's a feature, which is that you can put normal Zig code in calling convention naked functions, which you can't do with naked functions in other languages. They generally restrict it to just assembly. So, I mean, it's convenient in this case. I'm not sure if it has like necessarily well specified semantics.
That is a good question that I am not going to try to answer on this Showtime.
Fair enough. So yeah, that's a pretty big piece of the language. But the other thing I haven't really talked about is the fact that it's dynamically typed, and because we've just been using usize as our stack element, but in reality it can be a variety of things. It can be an array, it can be a floating point, it can be just a character, it can be an integer. There's a few other data types that are supported. So in order to do that, we use a kind of a NaN boxing approach, which is, again, this is similar, I think, to what V8 does. So the thing about floats is that they have certain representations which are all mapped to not a number. So the normal representation of not a number, it has like the first bit, the highest bit cleared, and then the next 11 bits are set, and then there's like one more set bit or something. But what we can rely on essentially is that for ordinary values, or ordinary float values, be they infinity or not a number or just normal float value, at least one of the top 11 bits is going to be cleared. And as a result, we can use types where, or we can use floating point values where the top 11 bits are all set, or the top 12 bits are all set to represent non-float values. And we can do that all in a single word, so we avoid having to store too much. We avoid objects on the stack taking up too much space. So what we've done here is I have a variety of different types. We have a distinction between small and big integers, so we can store 32-bit integers just without a pointer. And things are just kind of represented this way. There is one problem with this approach, which is that, like I said, the canonical representation of NaN involves the highest bit being cleared. But sometimes when you, for example, when you negate a value, it will oftentimes, the compiler will assume that it's fine to just toggle the most significant bit because that's the sign bit. And the problem with that is that technically the sign bit of NaN is not supposed to matter. But in our case, it does, because that's what we're using to distinguish, well, as part of the way to distinguish between floats and non-float values. So what I've done here is try to work around that, because if you just multiply by -1, that gets optimized to an XOR. So it's just toggling the sign bit. But what you can do is you can multiply by a constant. Well, it's a variable which you've exported, and multiply by that. And so because you've exported it, it assumes that you have to it has to read from it every time you do the negation, because some other code could be linked that modifies it. And it generates effectively the same code because you need an indirection anyway to refer to the constant. So
Clever.
yeah, that's some of the stuff that this does. there's a few problems I haven't fully solved. One of them is kind of the process of code generation. You can do it in two passes. One is to verify that well, you can do two things in the first pass, which is verify that the code is syntactically correct, and also determine how large of an array you need to allocate for the code. For example, here we have a routine which just assumes, A is going to take up 5 bytes, B is going to take up 5 bytes, because that's how much you need to encode call with a 32-bit relative address, and then you need an extra one for the return. So you can do that by just manually calculating it. But the problem is I want to make sure that these don't go out of sync, because if I accidentally have this underestimate how many bytes it's going to take, it's fine if it's an overestimate, but if it underestimates it, then you'll end up not writing enough, but you'll end up not, there might be some edge case, which is probably hard to cover through testing, where it doesn't, it overwrites the array that you've allocated. So what I would like to be able to do somehow is write this in kind of a polymorphic way, where it abstracts over whether you're doing the first phase or the second phase, so that these can't drift out of sync. It's a little bit similar to what the function standard.format.count does, where it sets up a writer which doesn't do anything, and then it sets up another writer that wraps that, which just counts the number of bytes that are read. And so when you pass in a format string, it's able to count how many bytes it is, and in fact, it's optimized down to just it doesn't even write the bytes. It just counts how many you would need. So I originally tried something like that. I'm not sure if that's necessarily going to work in our case, because the two passes are just so different. Because in the second one shouldn't have any sort of error that could be possible. In the first one, you need to return an error, and you're also verifying that the code is well formed, so that involves other checks. The two passes are quite different, even though the code paths will have the same overall shape, and I'm not sure whether it'll actually be possible to abstract over both of them.
Yeah, I have personally no insight, but that sounds an interesting problem, and I think relevant in general, keeping stuff in sync. That's a common problem.
Yeah.
All right, so you got a couple. Oh, sorry, go on.
Yeah, there was a couple other problems I wanted to talk about. One is because the language is dynamically typed, it would be helpful in some cases if you can just see from the operators that are that have been most recently executed what the types would be. It would be convenient to be able to omit some of the dynamic type checks in that case. For example, here maybe you could predict. So this B operator, it does base conversion, and you might know that both of these are integers. So this base conversion is going to convert the result into an array, and so you have an array on the stack just from these three operations. That kind of thing, I'd like to be able to do it, and probably that will work by having some sort of tables of how operators are overloaded for different types. The other thing is that CJAM is supposed to be a memory-safe language. So if you do something illegal, if you overflow the stack or underflow the stack, I do want there to be some sort of structured error and a backtrace, not just a seg fault. But at the same time, if you try to check for that on every push or pop to the stack, then that ends up losing some performance. So the idea I have is that you could probably allocate a space for the stack and then map the pages before and after that to be inaccessible. And then you set up a handler for the seg fault signal, which handles that correctly. But I'm not sure how good of an idea that is.
Could be worth a try.
I think so, yeah. So
It's also
yeah,
pretty
I guess
cheap
that's all I
to
have.
do. It's pretty cheap to do overflow checks on the plus, at least.
Yeah, that shouldn't be too bad. I think I'm just more concerned about the overhead of just stack manipulation, because traditionally that ends up being quite a source of overhead for stack-based languages.
Got it. Cool. Looking forward to seeing some more progress on this project.
Yeah, and these are just the pieces. I haven't really put anything together. I don't have this on GitHub or anything. But if you wanna know more about it, you can message me.
Nice. Well, if you get to
All right.
something working, I think writing in a blog post all the tricks that you had to come up with would definitely be interesting also for a wider population that might not necessarily be too knowledgeable or interested in exotic languages. Like my point is, I think it's interesting for a very wide range of people. That's pretty cool stuff.
Yeah, I'll see if I can do something like that. Thanks.
Neat.
Cool.
And
Thanks for coming on the show.
It's pretty cool.
Is there anything else that you want to say before we conclude the show?
I think that's it.
That's it? Okay. Well, Andrew, I will say I'll ask you the same question, and then we can finally go and leave our day, I guess.
Yeah, I'm hungry. Gonna eat some lunch.
Yeah. I'm sleepy. I think I need to go to bed.
Fair. That checks out.
Okay, then I'll see you at Handmade Sample. Is that it?
Yeah. See you there.
Awesome. Well, and that's the end of the show. Bye, Andrew. Bye, everyone. And
Bye,
see you
everyone.
soon.
This is how we